what's going to happen? Like, if I press end, what's the output of this code snippet? Nothing. Yes. Nothing. And why does this happen? Well, what is the value of the condition? The logical value of the condition? False, right? So, but what if I say, what if I said 1 e negative 320? I don't know the output myself. So, but I know it's close to the border of becoming 0, close to the machine precision. So, yes, you see. So, negative 320 is big enough for the machine, for at least for this MATLAB version, to make a difference between 0 and this value. But if I said, for example, 1 negative 340, then no, that's not correct. Which one? 1 e negative 340. So what does this mean? It means 1 to the power of negative 340, right? If I press enter, nothing is output. Despite the fact that 1 to the power of negative 340 is not 0, right? But for this laptop, for this computer, and for this MATLAB version, it's equivalent to 0. Right? So you have to be careful with the value of the variables that you use in if conditionals. Like, for example, if you use this number and there's just 1 at the end, it's still going to print you something. Okay. And then, like, for example, these sorts of statements. If you have an empty string, what does it evaluate to? I have it in the message. Boolean false, right. Nothing. But as soon as you have something in the string, then it evaluates to true, right? So these are a couple of rules that you have to keep in mind. There is really no logic behind them, just the fact that this is how MATLAB works. That's the convention in MATLAB, right? So it would be unfair to ask you to memorize this, but it would be fair to ask you to use it in a programming scenario, for example. So be prepared to experiment with these sorts of logical values if you're asked to, and you can always check them in the in MATLAB command line. So for example, for this one, again, it's gonna, what happened? So I have an empty vector. What does empty vector evaluate to? False. But it prints something when I press enter. Why does this happen? Because of the else statement. So I say if, but the logical value evaluates to false, so else statement is executed. And then the same thing for cell arrays. I think, with cell arrays you cannot use them in logical. So there is no conversion from cell arrays to logical values. So if I press this, then it gives me an error. It says conversion to logical from cell is not possible, right? Okay, so I think we are pretty much done then. And then I told you about these MATLAB built-in functions, which are really, really useful, especially a couple of them, like depending on how what type of application you have, you may find any of them useful. Is equal is one that I use most often. It checks the equality of two arrays with each other, both the size and the content of them, so the elements as well, and so on. But now let's just, by the way, there is also an isPrime function, which is really useful, and you could use it for part of your homework. So there's a function, built-in function called isPrime. If I say 123, is it prime number or not? It tells you if it is or not. It's not, because it's divisible by 3, right? How do you figure a number is divisible by 3? What was that? Yes. How do you do it?
You add up the digits.
Awesome. Yes. Okay. So you know enough math. Awesome. Right. So we have used functions a lot so far, but I haven't told you how it works and what are the components of function. It's really easy. You have first a syntax. A keyword function, and then in MATLAB that's how it works. I'll tell you what the use of function is in just a second, but the syntax is very simple. You mention the keyword function, and then you have a list of output elements, output variables, the correct word is, and then in the end you say you have the equality sign, the name of the function, and inside parentheses all the input variables to this function, right? So, but why do we use functions? What's the use of functions? Any ideas? Any suggestions? To output what?
To get an output we want that isn't a built-in function.
Yes, but what's the advantage of, because for example you could use the scripts, MATLAB scripts for to write your code, to do whatever you want. Excellent, yes. But with MATLAB, because you have a script, there is not a redundancy, but you feel the need for functions way less than other languages. In a similar way, if you go, for example, to Fortran, they also have so the Fortran standard also has something that is similar to a script, to the idea of a script, but there is also a function next to it. So there are two entities that help you modularize your code. One is called subroutine and the other one is called function. So in a similar way, MATLAB also has this redundancy, but each one of them has its own uses. Really, so there are places that functions are much more useful than writing a script. And there is also another difference between a function and a script. What do you think it would be? One of you asked me, why don't I get the variables that he defined in his function in the MATLAB workspace? So why do you think the variables that you define in a function will not appear in MATLAB workspace? Any ideas? You have something.
Independent of the function that we show in the workspace.
Yes, I think that's sort of correct. So basically what happens is that each function that you write, unlike scripts, has its own workspace. So you have a base workspace in MATLAB, the main workspace, which is this one, right? And any script that you write, whatever they create or destroy, all of them appear on this main workspace. But when you define a function, the function has its own hidden workspace somewhere that you don't see it. So as soon as you quit MATLAB function, those variables are all gone, right? You don't have access to them. So if you define a variable in function, you will not be able to see them here, right? So that's another difference. But basically that's all about functions. Now you can solve all the problems in homework up to like, I think the last question. But there are more complexities with functions. So this is all you need to have in a MATLAB script, in a MATLAB file if you want to create a function. But I highly recommend you to add an end keyword at the end of your function statements, your function file. So suppose this is my function, my func, and then this function actually does nothing. So end. Why didn't it? Something is wrong here. Oh, it's because of this. Okay. You remember what this is for? 3 dots. What is it for in MATLAB? Continuation. Yes. So whenever you have these 3 dots, the rest of the line is assumed to be a comment, right? So that's why it's green. So that's why we had this problem. So now if I remove it, then it should work, right? But MATLAB still gives me some errors. Not errors, some warnings. And those are about these variables that I have defined as output and also as input, but I haven't set anything for these values. So I'm not doing anything in this function, so that's why I get these warnings. But basically, what I wanted to tell you with this script is that it's always good to have the AND keyword. It's not necessary, but I would highly recommend you to have it. And when you have functions within functions, then you need to have AND statement, okay, or AND keyword. All right. And there is also a new set of rules in MATLAB 2016B. Mine is 2016A. I think yours is all 2017B, right? A? Okay. So you probably have all these functionalities, the new functionalities. Like, for example, you can write functions inside of other MATLAB scripts, to do things like this. But with the original MATLAB standard, you cannot put functions in any other files. Each function should have its own separate file. So if you want to write a function, myfunc, this function should be in a separate file for itself alone. And the name of the function should match the name of the file that contains the function, right? So you see, right now, the function is not saved, so it's called untitled star. And the star means that it's not saved yet. And if as soon as I press Control S to save this function, it gives me automatically, it gives me the name of the function, myfunc.m, right? So now if I save it, change folder, right? It does nothing for me because I don't have anything in it, right? So now, you know all the syntax. Let's try some functions then. Let's write a function. Don't copy it from this lecture. Let's try it yourself. So we're going to write a function that converts Celsius degrees to Fahrenheit. And do you remember what the conversion rule is? It's complicated. I don't remember myself, so I don't expect you to remember. Celsius to Fahrenheit formula. Okay, so it's this. So we're going to write a function which is called C to F, for example. Let me just make sure that we are converting. So we have, yes, so we have a function C to F. Let's try to implement this function and see what you get. So you have, as input, you have a temperature degree in Celsius units. And then on the output, you have a single number, which is the Fahrenheit, the temperature in Fahrenheit, right? So it should be easy to code it. Try it yourself and see what you get. And then once your function works, I'll tell you what value to test. Try a temperature of 70.7. And if you need help or have questions, ask me. Don't hesitate to ask. Oh no. So here's the thing. If you want to write a function and then run the function, you need to create a file first. You need to put your function inside a script file. Not a script, I mean a MATLAB file, M file. All right? So what you do is that you go to your MATLAB and then press Control N. It's going to open a new window for you in the MATLAB editor, a new file, which is called Untitled2, right? Now you start writing your function. The name of the function is C2F. So I say function C2F, which means convert Celsius to Fahrenheit. No, this is not the case, so I have to write F. f equals c to f, and then c. That's it. End. And now, if I press Control S, it's going to give me the option to save the file, save the function, and it automatically gets the name of the function that I've already requested, so c2f, and uses that name to create the file, c2f.m, right? And I say save it. Now it's saved as c2f.m. You can run the code. Now what you can do is that you can just call it from MATLAB command line. I can say c2f. It does nothing because I don't do anything inside of it. But now the point is to fill inside of this function with this equation. So that it gives us, it outputs the Fahrenheit degrees. When you create your functions, I also recommend you to write with a tab. It's optional. I mean, that's my own convention. That's my own habit. So you don't need to follow it. But I most often press a tab just to know that I'm inside of a function. Okay. So if I wanted to write this function, I would say f equals c times 9 divided by 5 plus 32. Okay, that's it. So now if I say c to f, it's going to give me an error. Why does this error happen? Yes, exactly. So I set c to f, but it gives me the error, not enough input arguments. So if I say, doesn't matter what you do, you have to input an argument because c is used inside of this function. So it should have a meaning. So you have to specify it and say, let's say we're going to try 70.7. That's the hottest place on Earth, hottest recorded place on Earth, which is about 159 Fahrenheit. Happens to be somewhere in Middle East, in the southeast of Iran. So, yeah, simple as that. But then you can do much more interesting things with functions. For example, you can define a function that does not have any input arguments, like the one that I have here. So you can define a function that gives you only information. What happened? Oh, so I cannot define a function on command line, I told you, but I make the mistake myself. So as soon as you press Control S, again, it auto-completes the name of the function for you, and it takes the name from the name of the function, the name of the file. So now if I say get ICP, and you press tab, it can autocomplete it for you, and you don't need to input anything because that doesn't take anything, and it just prints some message for you. Okay, you can have a function that doesn't have any output for you, the reverse of this. So I could say let's say I should have an example here. Yes. So pay attention to syntax. When I don't have any arguments, input arguments, there's nothing here. When I don't have any output argument, the syntax is different. You don't need the output part, right? So here in this function, I have info as an output, right? So what I can do is that I can remove this info, and then this function doesn't have any output anymore, right? So let's try this. I have another function, get ICP info, and I have removed the output of it, right? So now if I save this, oh, there's a file already with the same name. So I think we could just close this and remove this one, modify this. and then you could leave info there, but it's no use. MATLAB gives you a warning that you're not using this info variable. So I could simply add a display statement here instead. Now, if I save this and then I call this function, there's no error anymore. Okay. Oh no, but I'm sorry. There's no error because there is no input argument, but there is no output argument. So now if I say output equals get ICP info, what do you think I will get? If I try to set this function equal to a variable, what I'm doing really here is not really setting this variable equal to a function. What's really happening is that I have, when you have this equality type of statement, where on the one side, on the left side, you have a variable, and on the right side you have the function name, you're basically requesting the output of that function to be set in that variable, right? So if I say this, then it's going to give me an error. Too many output arguments, right? Because this function, get ICP info, doesn't have any output argument. Now if I say info equals this, and then add a new line that says info equals this message, then I have an output. You see? So now if I say output equals get ICP info, it's not going to give me any errors. Now if I say what is output, it outputs the message for me. That was the output of the function. Alright? So just to wrap up again and summarize, if you don't need any input arguments to your function, simply just have parentheses here, nothing else. Right? If you don't need any output for your function, then just remove the output arguments and the equality sign. That's it. And you're done. Okay? But this is not really interesting type of function. Yes?
Just a quick question. For the other one, for the Fahrenheit,
yeah.
Like you had another part to it, as well as the function itself.
Oh, what is it?
Stuff on it. Like, I was just wondering, like, what would that be originally?
Oh, so that's actually, I just wanted to give you some information about the hottest place on Earth. That's it. But basically, you could write this in a script. So what you do is that functions are really just like a small boxes that contain pieces of your code that you're going to use over and over in your lifetime. So you put your functions, the set of tasks that you do it repeatedly in modules called functions, and then you write scripts that call those functions whenever you need them.
So it's okay to, like, so you write a separate script?
Yes, absolutely, yes. So let's write a script. So I call it my script for now. So I have this script now, which contains this information. The temperature in Celsius, which is this, and then the Fahrenheit temperature, which is the result, the output of this function C2F. As long as the function exists, the function file exists in the directory of MATLAB, in the working directory of MATLAB, or in any of the paths that is recognized by MATLAB, you're fine. Because MATLAB automatically searches the entire path list and finds something that matches the name of the function that you're trying to use. Okay. But so right now, you see the working directory for my MATLAB is desktop folder, right? And both the script, my script, and C2F are on desktop directory. So if I press F5 now, it will run the code without any problem. It did it, but you didn't see it because. So, what was the command to clear MATLAB? Is it clear? No, it clear. If it's no, it's I think it's CLC. Okay, there's another one. I think this is for Windows Terminal, right? CLS or I don't. Oh, it's for basic language, right? So now we want to run script my script. Press tab. You see, without any problem, it runs the script, and in the middle of the script there is a call to function C to F, and it calls it, runs the function, gets the output, and prints it for you. Right? But suppose I remove this function C to F from this place. I put it I don't know, I put it in the ellipsoid folder here. Okay, now function C to F doesn't exist in MATLAB working directory anymore. Right, now let's see what happens. If I try to run my script, it says undefined function or variable C to F. Right, so this function that I'm calling in my script doesn't exist anymore. It says line 2. If you click on line 2, it's going to take you to the exact line that calls C to F. But it doesn't exist anymore in MATLAB working directory, which is desktop, right? Because I just moved it to another folder. So if I save this, I don't know where this function is saved even now. Yeah. So is there any question? Okay. So, but these are not really interesting cases when you don't have any input or output argument. Most often you need multiple input or multiple output arguments, right? And to do so, it's just like the basic syntax that I showed you at the beginning. You have multiple input arguments in the parentheses and then the result on the other side. Okay, so you could write, for example, a function that takes the exponentiation. So does the exponentiation for you, not here. So I could say function result equals my power. That's how I define power, which is not this. In my world, power means base times exponent. Okay, so I could do this, for example, or just say plus, whatever I want. That's my own function. But if I define it as exponentiation, then that matches the true meaning of exponentiation. So let's save this my power.m. Now if I call my power, interesting. So it can even autocomplete it for you. So if I say my power, then base is 10, the exponent is 2. What will be the output of this function? 100, yes. What happened? Oh, yes. Power is right. So if you code in C, there's a function called pow, right? Remember that? Has anybody coded in C? Yes. So you have a pow function, and I think in MATLAB there is also a pow function, or pow2, no. So how does MATLAB? No, there was for each MATLAB, if you remember, for each MATLAB operation, there is a corresponding function, right? And I don't remember which one was for exponentiation, so you may be right, but I didn't hear what you said. Oh, it's called power. Okay, so it's not pow, right? So if I say power 10.2, it should give me the same result. Yes. So my function works fine. And now in your homework, you're supposed to write a function that finds whether an input number is prime or not, right? And then you can check your answers with the built-in function. The MATLAB built-in function is prime, and see if your function is prime or not, right? So now let's move on to more interesting cases in functional programming. Okay, so here's another interesting case where you don't know, for example, how many input arguments the user is going to give you as a function input, right? So what do you do in that case? If you don't know how many arguments you're going to have, I think a good solution is to just use an object like cell that takes a list of arguments as cell elements and then you can parse it in your own function and use them. For that reason, MATLAB has a built-in object that is used for getting information from the user in your function, and that's called var_argin. Okay, so that's a keyword. So var_argin, whenever you have you want the user to be free in the number of input arguments, you can use var_argin, and all the variables that appear before var_argin are fixed input arguments. Those are arguments that have to be given by the user, and whatever that's in var_argin is optional. So it could be just one element, or it could be 100 elements. That's something that you determine inside of your code later on. So for example, let's say I have this function var_list. Let's try it. So let's define var_list here. So what does this function do? First of all, what's the output of this function? I told you, how do you determine the output? You say function keyword, the output equals the name of the function, the list of input arguments, right? So this function, does it have an output or not? No. Okay. So it doesn't have any output, but it prints something on a screen for you. And this sort of coding is actually bad. So I don't recommend you to write functions that have side effects. This is called a side effect. So when you write a function, you have to make sure that, I mean, you do not necessarily need to do this. It's not illegal, but it's bad coding habit. So when you write a function should be like a black box. And the user doesn't know anything about inside of it. And it only gets one input, so it has only one gate as input. And then there is only one gate as output. And nothing should happen on the side. So there shouldn't be any other gate before outputting any information, right? But this function that I have it for you there, it doesn't have any output, but it prints messages as side effects, right? This is really bad programming habit, so you shouldn't do this. Your function should always work with input arguments and output arguments, nothing else. Should not change anything else. Should not change the behavior of the program. And with printing, it's fine, because printing messages is not something serious. But if you, for example, try to change the value of a global variable, the variable that is defined inside the function and also outside the function, which we will get to soon, then crazy things can happen. Because, for example, you change the value of the variable inside of the function and you forget it, and then somewhere else you see that your code is giving you wrong answers, and you don't know where the problem is. And after 2 weeks and a couple of heart attacks, you figure out that, for example, it's in the function that you wrote that has side effects. So keep in mind that your function should always avoid side effects, meaning that every input should be given through this argument list here, and every output should be given through the output argument list, which is in the function header. All right. But for now, it's fine, because you just want to learn how to use var_argin. So I have a function var_list that takes year as the first element, first input element, and then a list inside var_argin. It could be anything that I want. Right. Now I can call this function like this. So the name of the function is var. Oh, I haven't saved it, by the way. So the function name is var_list, so .m. So it's now saved. Now I call this function from MATLAB command line. The first element is year, so I just set it to 2017. And for the rest of the elements, I could just have as many arguments as I want, but for now, I just say, what a nice weather. It's actually very nice outside. So if I press enter now, this is what happens. So I have a list of prints here. So I say f print f. We haven't got to this function yet. I think probably soon. It's a very primitive function that gives you the ability to print a string and then print numbers or other things, other objects in MATLAB in a formatted way. So when I say percentage symbol D, that means use digit formatting, right? So nargain is the number of arguments in var_argain. So I have, for example, how many arguments do I have here? 4, right? In addition to 2017. So what do you think I should get? 5. Or no? How many do you get? I think, oh, okay, yes. I think I made a mistake. So it also counts the first element. Yes. So the number of arguments, this 5 is nargain. And it gives you the full list of the total number of input arguments. And then cell display is a function that displays cell elements in an elegant way. And then fprintf, I told you. And by the way, what is the meaning of \n? Next line, yes. So there are a couple of characters like this. So when for example, these are called escape characters, right? And I'm not sure what other names they have, but most useful ones are this, which means what? Tab. So \t means tab. So what it does is that it inserts a tab character at the end of the line. But when I say \n, it means insert a new line character. So when you get a new line in your text, it's not really, so basically new line is a character that is set at the end of each statement that you have that you want to end and go to the new line. And then your editor understands that character new line and converts it to something visible for you, which means going to the next line. So if you don't have this n, what do you think will happen? \n. So if I remove this, let me add it first. So I have this, it says number of arguments, print nargain, and then this message. So it says number of arguments 5, and then the next line var_argain, right? But let's try and see if we remove this, what would happen. Hopefully something good will happen. Okay, you see what happened? So this fprintf, it says number of arguments, print 5, and then goes to the next line. But when you print a message, it doesn't go to the next line, right? It continues on the same line. And that's the functionality of printf. That's why I told you it's a primitive function, because it doesn't automatically take you to the next line, right? So you have to explicitly tell fprintf that I want you to go to the next line at the end, right? So anyway, we'll get to fprintf soon, but this wasn't the point of this function, the point of running this function. So now, basically, if you have variable number of input arguments, you can use var_argain keyboard in MATLAB, right? And then the number of arguments to the function are given by nargain, and then in the end, suppose you have a function that has variable number of output arguments. How would you deal with that? Instead of variable number of input arguments, you have variable number of output arguments. You have var_argain for input arguments, so you could have var_argout for variable number of output arguments, right? So there is actually one for that purpose, which we'll get to in soon. But before that, if you have worked, for example, in Python or Fortran, you will notice that you can have optional arguments. So you can have a list of input arguments like this. For example, you say call my function, which is var list, and then you say year equals 2017, and then for the next one, you could just keep a couple of arguments and then say the next argument, for example, nice equals nice, and so on. And ignore any of the arguments that you want, or keep as many as you want. But this sort of optional arguments doesn't exist in MATLAB, sadly, which is really sad, because it gives you a lot of flexibility what argument you want to keep or what argument you want to do. Yes?
So keyword arguments and you don't get it in MATLAB?
No, you don't get it in MATLAB, which is, yeah, very, I don't know why they do not add it, because even Fortran does have it, which is really cool. It means that you can just list your input arguments on a couple of lines and then comment whatever you don't want anytime you want, right? And then the function, the compiler or MATLAB Python interpreter automatically understands which arguments you dropped and which arguments you kept, and then automatically sets those that you have dropped to the default value, right? But there is no such thing in MATLAB, but there is a concept called parsing input arguments. And MATLAB has some functionality that gives you a similar behavior, and it's called input parser. So what you do is that you input as many arguments as you want to your function, and then you use input parser to find out which arguments the user has provided to you. I've never used it myself, but I just wanted to let you know that there is this functionality in MATLAB, which gives you some feeling like Python, Fortran, and C++. Right? Okay, so now about the output arguments, we're pretty much done. I just want to tell you that if you have multiple output arguments, all you need to do is to have a square brackets and then name the variables that you want to use. For example, let's write a function that takes a vector of x and calculates the sum and the square root. Try it yourself. Or maybe, because the solution is there and you're probably like, I don't know, you're tempted to use the copy-paste there. Let's try this. Write a function that takes in three coefficients, a, b, and c, and finds the root of this quadratic function, a x squared plus bx plus c. So what is the equation for quadratic root? Do you remember? So if you have ax squared plus bx plus c equals 0, what are the roots of this quadratic function? X equals, I don't remember it myself, so you should help me. B plus minus a negative b, yes. Plus or minus? B squared. Oh, b squared, okay. Minus 4ac. Okay, now I remember things. And then divided by 2a. Yes? Okay. So all you need to do is to implement this. Let's do it right now in 2 minutes. And then we can continue on Wednesday. Yes?
For the homework, do we just turn in each function that we write?
Right. So for those problems that require functions, you just write your function in a separate file. It's all okay with me. So you can just create a separate MATLAB file, .m, and then put your function for that problem in that file. That's all fine. Yes. If you don't use the new syntax, that will be wonderful with MATLAB. Because with the new MATLAB, you can put functions inside of your script, but I cannot run them myself with my MATLAB. Because my MATLAB is version 2016A, and that doesn't accept this new syntax and standard. So the best solution is to just put your functions inside of file names that have the same name as your function, right? So you suppose you're going to write a function called Fibonacci, right? So you say function, the list of output arguments equals Fibonacci, the list of input arguments, and then the name of this file the file that contains this function, should also be Fibonacci.m. Otherwise, you will not be able to run it on MATLAB. Okay. So it's really important. The name of the file that contains the function should be the same as the name of the function. Okay. And with the kind of information that you have now, what I told you today, you should be able. We have reached the end. So, and this is probably the last example that I have here is about var out. So if you have variable number of output arguments, you can use var out, and it gives you a simple example of doing this. But now with this information, you should be able to solve all of the problems in most of them, except the last one in homework. Yes.
When you do the myPower function, you put return at the end of it. Like,
No, there's no need for return. But you could use return. That's a good point. So whenever, for example, let's say you write a function, and you'll actually need this for your homework. So let's say you have a function, and inside of it you do some task, and then you have an if block, and say if something happens, you want to quit this function, return to the MATLAB environment. So you just say return. That's it. End. Okay. But at the end, you don't really need return because it reaches the end of the function. That's okay. You can put it or you can just remove it. It doesn't matter. Is that the answer to your question?
yeah, it's just because like it was in the
In my example? Oh no, it's not necessary, but it's a good keyword because it gives you the ability to cut your function and just return to the MATLAB environment whenever you want. As soon as you say return, it returns to the MATLAB environment. Yes, goes out and ignores the rest of the function. It goes out, yes, completely. I'll see you Wednesday. Thanks for
Amir, what are the values of A, B, and C? I just want to test it real quick. What are the values?
Oh, the three values. Anything one. 1, 1, 1.
1, 1, 1. But that might come up with unreal answers.
That's okay. I think it should give you a complex answer. That's right.
Oh, really?
It should, I think so, because... oh, okay. So then it's calling the hands So try 1, 2, 1. This should give you an answer.
1, 2, 1.
You got more. So 1, 2, 1 means it should be negative 1. Yeah? I have my function. Probably you didn't save it or you saved it not in this board. Is that in the import? Yeah. So why not? I think always the same here. 400. How could you do this? You have an input argument, but you don't use it.
Oh, I got it.
Is that negative 1?
Negative 1, negative 1.
Okay, good. Yes. So you remove this. You don't need it.
That's all the math.
Can you save it and then run it?
I can't get any kind of this math already.
Okay. Awesome. So it works, but then let's Control C, do Control C, and then break it. Just press anything. Like, what's the control? Oh, you have control. So press Control and C. Awesome. So you press. Now let's type it again. C to F, C to, and then press Tab. So it's probably at the end. Because we have so many functions. Yes.
Okay. Alright, thank you.
Yeah.
So just to be clear, you have to save every single function you write in its own file.
Oh, sadly, yes. But not in the recent MATLAB version.
Okay.
But still, just as a habit, because I'm an old guy, so
Making the reading.
Is it yours? What?
Was this yours or?
Someone else.
That's not mine.
Okay. Thanks. We should get out before the owner comes. Let me